All right, guys. Good afternoon. Welcome to Mr. Morrow's algebra class. Today we're going to be talking about 1.7, which is absolute value equations. Absolute value equations are the same as any other equation except they're going to have two sides. I'm going to explain that to you. A lot of times people don't even know what absolute value is. So let's start with the beginning. Absolute value is the distance from zero, which is represented with the following symbol. It's basically, it looks like two parallel lines. Whenever you have a value, a number, or a quantity, or a variable inside of the absolute value, okay, that value is going to be positive. The absolute value of anything is always positive. Why? Because since absolute value is a distance, can I have a negative distance? Okay, think about it, guys. Can I go negative 5 feet? Can I grow negative 2 feet? Can I gain negative 5 pounds? Can I go into the air, underwater, negative 20 feet? No. Can a wall be negative 15 feet tall? No. The distance from zero is always going to be positive. Now, when we're solving absolute value equations, okay, it's very, very easy. But you must remember that an absolute value has both a positive and a negative root. What am I talking about? For example, if I give you the following equation, I say the absolute value of x equals 3. Well, the answer here is going to be both positive 3 and negative 3, and I'll explain to you why. When we're talking about absolute value, remember we're talking about distances, right? Distances. So, if x is negative 3, what is the distance from 0? 1, 2, 3, right? Guys, you see that? If x is positive 3, the distance from 0, 1, 2, 3. So the absolute value of both negative 3 and positive 3 equals 3. The absolute value of any number will always be the positive of it. Now, there are two roots to it. That's why x can be either 3 or negative 3. But the absolute value of that will always be positive. So there's always two roots to an absolute value. A positive root and a negative root. Remember that. Because knowing that absolute values have two sides makes it much easier to solve absolute value equations and inequalities. We're not going to talk about inequalities today. I thought that it was included in your book, but it's not. We're going to talk about absolute value inequalities when we get to the chapter on inequalities. So when we get to that chapter, we're already a little bit of a step ahead, okay? So let's talk about how to solve absolute value equations. Like always, Mr. Morrow loves procedures, steps. If you follow these steps, you're going to do really well. But a warning, if you still don't know how to solve a regular equation, this is going to be extremely difficult. So if you don't know how to solve an equation, I need you to focus on the videos and redo them. Maybe even redo the homework, okay? So, let's do this. What are the solutions of the absolute value of x plus 2 equals 9? Graph and check your solutions. Why do we check our solutions? Sometimes you will solve for a value that does not work when evaluated, when you plug it back in. So if you get a solution that does not work, you have to call it an extraneous solution. So then I'll show you what I mean by plugging it back in. Okay, so the procedure here. First step, isolate the absolute value. Is the absolute value alone here right now? No. What's happening to it? Being added by 2. So I'm going to subtract 2 to both sides, giving me the absolute value of x equals 7. Now, step 2. Split the equation or inequality into the positive and the negative side. Remember that I said that the absolute values have two roots, right? That's why this is very important. So you're going to go ahead and split it up into a positive side, which I like to call the mirror image. It's called the mirror image because, guys, when you look at yourself in the mirror, don't you see your own image? Okay, so the mirror image, nothing changes. You just leave it x equals 7. The only thing that happens is you get rid of the absolute value sign. Then on the negative side, you simply multiply the non-absolute value side, by -1. So in this case, x comes out of the absolute value, and you multiply the non-absolute value side by a negative, and that's it. You got your answer. X equals 7 or -7. To graph it, make a 0, plot a 7, plot a -7, the points on the -7 and the 7. Now we have to check it. Let's see if it works. The absolute value of 7 plus 2, it should equal 9. What's the absolute value of 7?
7.
What's 7 plus 2?
9.
So it works? That works. Let's see if it works when it's -7. The absolute value of -7 plus 2, does that equal 9? What's the absolute value of -7? 7 plus 2? So it works, and it works. So A, get the absolute value alone. B, split it up into the positive and the negative side. Then C, solve both sides, and you're done. Sir. You don't have to make the graph every time unless I tell you to graph it, but you do have to check it. Thank you, my man. All right. Starting from 100 feet away, your friend skates towards you and then passes by you. She skates at a constant speed of 20 feet per second. Her distance d from you in feet after t seconds is given by d equals the absolute value of 100 minus 20t. At what times is she 40 feet from you? What is 40 feet representing here in this equation? The distance. So we're going to evaluate. Remember, when we evaluate, you're just plugging in. So I have 40 equals the absolute value of 100 minus 20t. All I did was evaluate. Now I got to solve, okay? So remember, when I got to solve this, the first thing I got to do is make sure the absolute value is alone. Is the absolute value alone here in this case? Okay, some of you are saying no. How? Is something being added to this? No. Is something being subtracted from this? No. Is something being multiplied to this? No. Is something being divided by this? No. So again, is the absolute value here alone? Yes. Okay, so it's alone, so we got to split it into our positive and our negative side. Remember, the positive side is the mirror image. So it's simply going to be 40 equals 100 minus 20t. The negative side, you multiply the non-absolute value side by a negative. So this would be negative 40 equals 100 minus 20t. Does everyone understand that setup so far? Now let's solve. Let's solve the positive side first. It's a two-step equation. I undo addition with subtraction. So I subtract 100 to both sides. Negative 60 equals negative 20t. Divide by negative 20. 3 equals t. The negative side, subtract 100 to both sides. I got negative 140 equals negative 20t. Divide by negative 20. T equals 7. Now we must check it, because you can sometimes get a solution, but it doesn't work, and that's called an extraneous solution. So let's check. Okay, 40 equals absolute value of 100 minus 20 times t is 3. Okay, let's see if that works. 40 equals absolute value of 100 minus 60. 100 minus 60 is 40. The absolute value of 40 is 40, so that works. Let's check out the next solution. 7. 40 equals 100 minus 20 times 7. 40 equals 100 minus 140. 40 equals the absolute value of negative 40. What's the absolute value of negative 40? So it works. Both of these are solutions. Does that make sense? You're sure, guys? Because I got to move on. Yes, sir. They're both different numbers, but they both still work because I just proved that they worked. Right? That's why we check them. Thank you so much for asking that question. That's why we check to make sure and prove that they both work, sir. Thank you, sir. Remember, there's a positive and a negative root, bro. So that's why it's weird. I know. It's like, wait a second. How can that work with two different values? But it does. It does. Thank you very much. It's a great question. Okay, number 3. Is the absolute value alone here? Yes. Nothing's being added to it, subtracted from it, multiplied to it, or divided. So, split it up into my positive side, my negative side. My positive side, 3x minus 1 equals 8. My negative side, 3x minus 1 equals negative 8. Remember, you multiply the non-absolute value side by a negative 1. Now let's solve. Add 1 to both sides. 3x equals 9 divided by 3. X equals 3. The negative side, add 1 to both sides. 3x equals negative 7 divided by 3. X equals negative 7/3. Let's check it. Gotta check it. So let's see. Absolute value of 3 times 3 minus 1, does that equal 8? This is 9 minus 1, which is the absolute value of 8, which does equal 8. X equals 3 works. Let's check negative 7/3. 3 times negative 7/3 minus 1, does that equal 8? Well, the 3's here cancel. I cross divide. Negative 7 minus 1 is negative 8. The absolute value of negative 8 is 8, so it works. Both of these bad boys are valid solutions. Sir? I don't understand what you mean. No, why would you ever do that? You only split it up into the positive and the negative when you're solving the equation. When you check your answer, you use the original equation.
Yeah, I'm saying like the original, it would come out as negative first.
No. Think about it. His question is this. Can you have a negative, can you have an absolute value equal negative? What did we say right from the beginning of the class? An absolute value can never equal a negative. Great question. Thank you, sir. Okay, let's check this one out, guys. Is this absolute value alone? No. What do? How do I get rid of it? It's just like a regular two-step equation. Subtract the 12. Very good. I got 3 times 2x plus 9, and absolute value equals negative 2. Divide by 3 now. And then you should think about this for a second. Hold on. Can an absolute value side equal a negative 2/3? No, so this is no solution. Done. Yes, sir. Very good. The question was, Mr. Morrow, when the absolute value is accompanied by other values, other numbers, in this case it's multiplied by a 3 and it's added by 12, do we use this inside like the x? Yes. That's pretend that that's the x, and that's what I solved for, because that's what I wanted to isolate. So I subtracted the 12 and then I divided by 3. What did I isolate? The absolute value. Does that make sense, son? Does that make sense to everybody? Yes. Excellent questions. Excellent questions. Thank you. Okay, so that's a no solution. Bye-bye. Have a good day. That's all you got to do for that one. See ya. Wouldn't want to be ya. Okay. Here. Is this guy alone? So let's add 5 to both sides. I got 3x minus 6 equals negative 2. Oh, that's no solution. That's exactly right. Because an absolute value cannot equal a negative. So, the question is this though. Mr. Morrow, if I see a negative from the beginning, can I just say it's no solution? No. And let me explain why. Let me explain why. Let's just make one little change here. Let's make this a positive 5. So, I'm sorry. Let's make this a positive 15. No, let's not make that a positive 15. Let's make this a negative 15. Add 15 to both sides. Now I got 3x minus 6 equals 8. We can work with that, can't we? So you can only decide if it's no solution only when the absolute value is by itself. Now for giggles, let's just go ahead and do it. Positive side, negative side. My positive side is the mirror image. My negative side, you multiply the non-absolute value side by a negative. Yes, sir?
How do you suppose the first part after adding the 5?
Well, when I added the 5, negative 7 plus 5 is negative 2. Absolute value cannot equal a negative. Thank you. So now I add 6 to both sides. 3x equals 14 divided by 3. X equals 4 2/3. Add 6 to both sides. 3x equals negative 2. Divide by 3. X equals negative 2/3. And then you would have to check them, but I'm running a little bit low on time. So if you guys want, or do me the favor, check them on your own. See if they are real, if they work. Because I got to show you one more thing. Is that cool? Everyone with me so far? Okay, now, don't worry about this for now. And don't worry about this for now. Again, I'm sorry I even wasted paper on that. That was my bad. I should have paid more attention. I take full responsibility. However, word problems. Absolute value word problems are the ones that used to just drive me bananas. I would really have big problems with these absolute values because no one ever took the time to teach me what to do. So I had to figure it out, guys. So I came up with a formula. And this formula works always. And you're going to love me for this if you memorize the formula. Let's talk about what kind of an equation, a word problem we can work with. A company makes boxes of crackers that should weigh 213. So when something should weigh or should be, isn't that the goal? Okay. A quality control inspector randomly selects boxes to weigh. Any box that varies means changes. Any box that varies from the weight by more than 5 grams is sent back. So if it's over 5 grams too heavy, they send it back. If it's 5 grams less than what it should be, they send it back. Yes? Thank you, sir. So what is the range allowable? What is the range allowable weights for a box of crackers? You always want to set up absolute value word problems using this formula. The absolute value of x, you just put x, minus the desired value, that's the goal, is less than or equal to the change. Remember, the change is what it varies. So it's x minus the goal less than or equal to what it varies. You with me there, guys? Yes, sir. No, it's desired in parentheses goal. That means that it's either or, sir. Either or. Either or. It's not multiplied. Thank you. Good question. The desired is the goal. Right? Does that make sense? Okay, so looking at that formula, let's look at the values that they gave us and let's see if we can figure this out. A company makes the box of crackers that should weigh 213. That's my goal. And it varies by no more than 5 grams. So check it out. x minus the goal is less than or equal to 5. It's that easy. Because 5 is the what it can change. That's what it can vary. Now, same as always, guys. Same as always. Let's go ahead and make a positive and a negative side. Positive side. X minus 213 is less than or equal to 5. Negative side. X minus 213 is greater than or equal to negative 5. I don't know if anyone noticed, but why did I flip the inequality there? Correct, because I multiplied that side by a negative. Whenever you multiply or divide anything by an inequality by a negative, you must flip the inequality. Yes, sir?
What about when it's like the signs are greater than or equal to?
It doesn't matter if it's greater than or less than, or you always flip it.
Actually, the left side is not.
No. On this right side, on my negative side, I multiply by a negative 1, right? So when I multiply or divide by a negative, I flip the inequality. Thank you. Great question. So now, let's solve it. Add 213 to both sides. So x can be less than or equal to 218. Add 213 to both sides. Or x can be greater than or equal to 208. So my range is x could be greater than or equal to 208, but less than or equal to 218. Anything in between those ranges will work. And that is how we do this. It's a little bit easier than you used to teach you, wasn't it? It's all about the equation. Memorize that equation. Memorize it. Okay, my brothers? Let's do another example, my brothers. Let's do another example. Let's say I have here a food manufacturer makes 32-ounce boxes. That's the goal, right? That's the desired. That's what it should be. He makes 32-ounce boxes. They don't want to make 38-ounce boxes or 39. They want to make 32-ounce boxes. Not every box, though, exactly weighs 32 ounces. Write and solve an absolute value inequality to find the range of allowable weights. Well, let's say that the company allows 0.5 of a gram of an ounce variance. Okay, they allow half an ounce variance. It can vary by half an ounce. I want to know what are my acceptable ranges. Well, the absolute value of x minus the goal is less than or equal to the change of 0.5. We got a positive side and a negative side. My positive side is my mirror image. X minus 32 is less than or equal to 0.5. My negative side, x minus 32, is greater than or equal to negative 0.5. Why, Mr. Morrow? Because I multiplied that by a negative 1. Whenever I multiply or divide by a negative, when I'm dealing with inequalities, I must flip the inequality. Yes, sir. No, when you're doing the mirror, when you're solving, you got rid of the absolute value. Remember, we got rid of the absolute value because now we're finding the positive and the negative side of it. Does that make sense, sir? Thank you. So now let's solve. Add 32 to both sides. X is less than or equal to 32.5. So it's got to be less than or equal to 32.5 ounces. Add 32 over here. But x can be greater than or equal to 31.5 ounces. Are you okay? Okay. So guys, you have x is less than 32.5 or greater than 31.5. When you're writing this out as an answer, put x in the middle. Start with the lower value first and then go to the higher value. So go lower value and then higher value. So x is greater than 31.25. That's my lower value. I'm sorry, 31.5. Sorry. And then it's less than or equal to my higher value of 32.5. So in the box manufacturer company, if I'm the quality control expert, will I accept something if it's 32.4? Yes. Will I accept something if it's 31.7? Will I accept something if it's 33.2? No. Does that make sense, guys? Awesome. Awesome. Yes, sir. Okay. The question is, can we just add or subtract the 5, Mr. Morrow, because it's so simple? No. Technically, you could. But what happens when I start complicating things? Then you're not going to be able to use this because you haven't practiced it. My friends, in my class and out in the internet world that's watching this, don't take shortcuts with math, please. Follow what I'm telling you. Practice it exactly the way I'm teaching it to you. And I promise you, you're going to get better. Thank you very much and have a wonderful day.